Hey guys, welcome back to the channel. Welcome to another video. Thanks for joining us, and especially on our next journey on this Linux journey that we're doing here. Lovely, big fan of the Linux journey series. So if you guys have been following the channel for quite some time now, we've been learning all things about Linux. If you're finding me for the first time, guys, I say this in a lot of my videos, go ahead and make sure you start from the beginning of the series and watch each video so that way you can get caught up into where we are today, because the ideas and the concepts, they do build on each other. I don't want you guys to get lost. So if you're finding me for the first time, welcome. But go ahead and take a look at that first video and make your way up to this one. But for those who have been following the series, also another welcome to you as well. And let's tackle the next portion of that Linux series. And in this video, we're going to learn a lot about what we call the Linux file system. And we're going to learn a couple of key items that are very important. And this is going to be a light class for today, or a light video, should I say? Well, actually, maybe it might be a class. I feel like I do teach a lot here on YouTube. But anyways, another topic. But again, we're going to talk about just the Linux file systems in general. How do you access it and what certain things mean? And you're going to learn a couple of cool little commands for today. But as always, guys, let's take a pause. But as always, guys, if you appreciate my videos and they're helping you out a lot, make sure you go ahead and give me a like for the algorithm, as it helps the channel grow. Go ahead and subscribe to the channel and turn on your notifications so that way you're notified when I upload new videos to the channel. And lastly, of course, share this with a family member or friend who's interested in learning. And by the way, guys, a lot of you have been leaving me comments, some technical comments, or you've been emailing me. If my comments or my emails are not enough of a response, meaning you need a little bit more details, in the links of in the videos, in the description of the videos, you'll find links to my calendar. You can go ahead and book time on my calendar, be able to speak with me, and we can go into further details, or we can troubleshoot something that you're having issues with. So, all the pleasantries out of the ways, guys, let's go ahead and jump into our Linux desktop. And as you guys are seeing here, I have a terminal up already. And that's what I mean by the ideas built on top of each other. You should know what a terminal is, and you should know how to bring one up. So first things first, let's go and tackle the first topic that we have here. And I wanted to bring up a command that I use this all the time, and I think I actually may have used this in past videos. But if not, let's talk about it now. And it's the lsblk command. So let's take a look at lsblk or lsblock. Now, there's many ways to say it. And let's take a quick peek at the man page for it and see what it is. So the command stands for list block devices. And you can see here in the description, right, lsblk or lsblock lists information about all the available or the specified block devices. Now, what are block devices? Well, block devices are typically like hard drives, media devices, right? So if you have a flash drive that you're plugging in, things of that nature. So as I've told you guys before, and as you've seen in my series, this machine that I teach you guys on is actually a virtualized machine. So it's a virtualization software that I use called VirtualBox, and I showed you guys in prior videos how to, use that software. And then that software sits on an operating system. And in my particular case, I have it on Windows for now. But once you have your Windows operating system and you have your virtualization software in order to virtualize another operating system, that is where the next operating system sits. And of course, we have Linux here. And so if we were to take a look at lsblk for now, you'll see here a bunch of different outputs. And we'll touch on exactly what that means and why it is that you have certain things here. So the first things first, right, as we look at this ls block, no. So now that I broke down exactly the whole setup that I have, remember, Windows is my base host operating system. Then you have your virtualization software that sits on top of that, which is VirtualBox. And then now I can have a bunch of guest operating systems. And of course, one of the guest operating systems that I have, you're seeing here is RHEL. And so when you're seeing the output of LS block like you're seeing right now, some of it has to do with things directly tied to the virtualization software. And that's why I bring that up and why we're talking about the relationship between what is what is the output of this ls block and how it relates back to virtualization. So while we're on that topic, actually, let's talk a little bit about why we have certain things from a virtualization perspective. So here we have two devices or block devices that are listed. I have SDA and then SR0. And so from a virtualization perspective, SR0, you're seeing here, it says run media El Acosta VBox guest editions. So if we actually take a look at, let me bring up my little bar down here that gives us all the settings for VirtualBox. If we take a look at under devices and we go under optical drive, you can see here that it has an option under optical drive. It says remove disk from virtual drive. So essentially, I have a disk that is inside of here. And let me show you guys exactly what that disk is. By the way, the hint is right in front of the, by the way, the hint is in the terminal. But anyways, I'll bring it up a little bit. But anyways, I'll bring up another screen so that way you can see in well, not in details, but I'll bring up another screen so that way you can actually see not only from the terminal, but you can actually see it in the settings of the virtualization software. So here we have our settings for that virtual. So here we have the settings for VirtualBox. And of course, this is for the RHEL 8.7 that is running right now and that we're working with. Now, if I were to go into storage now, you'll see here that I have a controller, an IDE controller, and a SATA controller. Now, the RHEL 8.7 VDI, that is the virtual hard drive, right? So that's essentially a virtualized hard drive that connects to this virtual machine. And you're seeing here that it has a virtual size of 100 gigs. And I'm actually using about almost 30 gigs of that. Okay, cool. If you haven't figured it out by now, that is SDA, the first one. And you're seeing the size. Look at it right there, 100 and 100 over here. But let's start off with what we were originally talking about, which is SR0. So SR0 is the IDE controller, and that is essentially like I have a um, so the IDE controller is essentially as if I had a CD-ROM drive inside of this virtual computer. And the disk that I'm put in is the VirtualBox Guest Edition, which is a size you're seeing here of 57.44 megabytes. And by the way, if I take this out of the way, that is exactly what you're seeing here. SR0, that's the block device, is that CD-ROM drive that I just showed you, and it's mounted in this path over here. And what do you know? There's the size, 57.4 megabytes. Or, as you saw in the Windows side where I showed you the virtualization settings, it showed you that it was 57. Let me bring this back in here, 57.44 megabytes. Cool. Now the second one, and we talked about it a little bit earlier, the second block device is SDA. And SDA is the virtualized hard drive that I have. So it's 100 gigs in total size, and I'm using 30 of that, almost 30. So you can see that right over here, 100 gigs in total disk size, and I'm using about 30 of that. Now, here's the other really cool thing, and we'll talk about this in details in another video, but if you're wondering what is SDA1 and SDA2, well, it actually both connects back to SDA, and that is called partitioning. Now, we'll go in deeper dives into this in another video, but essentially all it is you're taking a hard drive and you're cutting it up into multiple sections, and each section is available only for certain things. So if you're seeing out of the 100 gigs, I have 1 gig is dedicated strictly for the slash boot partition. And then the other one is dedicated for the rest of the operating system. So slash home. And you're seeing here that the 99 gigs is, look at this. You have 65 gigs for slash, 2.1 gigs for swap, so on and so forth, right? But together, meaning your 1 gig here and your 99 here, SDA1 and SDA2, is equal to the total of SDA, which is 100 gigs. And this is a really cool command that I use in order to see the block level devices on the particular machine that I'm working with. So that is the first item that we're working with today. Okay. So now that you know, how to look at the block devices, how do we go ahead and examine these block devices? And we can take a look at the file systems, right? We understand what that is. So now that you've seen the block devices and you're interested in saying, well, how do I examine these block devices further? There's two additional commands that I'm going to teach you guys, and those commands will give you some really nice information when you're looking to examine those block devices. And the first command that we're going to use and we're going to go over is called the df command. So let's take a look exactly what the df command is. So if I were to do a man df, you see here that it reports file system disk space usage. And of course, you can go ahead and read the description, and it gives you a whole bunch of stuff on that. But in the interest of saving time, we're going to exit out of here by hitting Q. And so let's just run the df command and see what we get. And so you get a bunch of different output here. And it's interesting because it gives you the file system, it gives you the use space, available space, it gives you the 1K block column, and all kinds of other information. But before I, before jumping into, no, I gotta. So let's take a look at this output a little bit further. That way we can discuss exactly what we're seeing here. Now, real quick, guys, I'm going to show you two different ways that we can actually. No. So let's talk a little bit about exactly what we're seeing here and what all this stuff means. So let's take a look at our file system columns, and we have a couple of things here. We have our devtmpfs, we have tmpfs, and then we have a lot of dev devices, exactly dev slash mapper, dev slash SDA1, dev SR0. By the way, guys, we're going to knock out some quick ones really, really quickly because it's very self-explanatory. So SR0, SDA1, of course, those are your block devices. We just talked about them, right? They're right up here. SR0, SDA1. Now, why is this slash dev? Well, in the previous Linux videos, I have told you guys to take a look at the Linux file system hierarchy. And if you look in there, you'll know that the slash dev directory or the slash devices, that directory is where all of these block devices live. So once you read that, you'll understand that. That is very, very simple. Now, same thing if we look at some of these other ones here, right? So SDA1, SR0, we finished with that one. Let's take a look at devtmpfs and tmpfs. What does that mean? No, let's do that again. So we just knocked out SR0 and SDA1, so we're all set with that. That's pretty self-explanatory. Now, what exactly is the slash dev mapper, right? There's two of them here. And if you see here, that is actually where your slash directory is mounted. And this one is where your home directory is mounted. And by the way, those directories are tied directly to SDA2. So if you look here, SDA2, you have your slash directory. That is your rel root. That's why it's called rel root. Excellent. And then you have your rel home, which is also your slash home. That is your mount point. And you can actually see that here. Rel home, rel root. Both are mounted in your slash mount point and slash home mount point respectively. So you can see how all of this stuff ties together. Very, very simple. So we knocked out all the so so at this point we knocked out all the slash dev devices, right? SDA1, SR0, our mappers, which includes both rel root and rel home. Now let's tackle the last two that maybe is not clear exactly what it is, but we'll talk about it briefly so that way we can understand. You have your dev tmpfs, and then you have your tmpfs. What exactly does that even mean? Well, let's start off with the tmpfs first. Now your tmpfs, essentially that is a general purpose file system that is temporarily available to you when the computer is on. And that file system lives in memory, so typically your RAM. Now think about it this way. Whenever a computer turns on for the first time, especially a Linux computer, it has to create temporary files. Now, you don't want to save those temporary files because you may not need them, right? So you don't want to fill up the hard drive with a bunch of garbage in a sense, right? You want to keep things for long-term storage. That is the purpose of the hard drive. But those other files that may be temporary log files, temporary run files, things that you don't need in order to run, things that you don't need after the computer turns off, you put them in these directories. And so essentially, tmpfs stands for temporary file system. And you can see here, if I go on the mount point, you have your slash dev. And so if I look at the mount points, you can see here that your slash dev slash shm is one of them. Your slash run directory is another, right? If you look at all of these are temporary things that are needed in order to run the machine, but we don't really necessarily need to save them for long-term purposes. And that's why we have these stored in memory. And when the computer turns off, because we know that memory essentially is volatile, meaning that when the power goes off, everything in memory is lost. And so in this case, it's a perfect example of why you would put these items in this temporary file system. By the way, guys, your slash tmp, your temporary directory, that is also in this. By the way, guys, we can actually leverage the same command and point it to a directory to see what the file system is. And if you've noticed, your slash tmp or your slash temporary directory, temporary for temporary files, if we were to do a df on that directory, we should see that the file system is tmpfs. And that's a way that you can check to see what file system is associated with a particular mount point or a particular directory. So if I were to say df slash tmp, no, we're going to have to fix that. Slash run. Df slash var. Okay, so here, let's take a pause here. So we just went over what tmpfs means, so temporary file system. Let's talk lastly on the last one, which is devtmpfs. What exactly does that mean? Now, this stands for Device Temporary File System. Now this now this is a specialized file system and it's really temporary for Now this is a specialized file system and it's of course temporary, and that temporary file system is dedicated towards devices. So every single time that I go ahead and let's say I'm interested in plugging in this USB device, well, that is the device now that the Linux operating system needs to be able to mount. And so these devices, they get plugged in and out, meaning you can take them out of meaning you can unplug them from the computer any given time. Remember also too that whenever you are remember also that when a computer remember another thing as well is that when you're turning on the computer, another thing as well is when you're turning off the computer and then you're turning it on, these devices that are plugged in, meaning your hard drive, they may or may not be in the same device name as before. It's a possibility that SDA1 can turn into something else. No, let's take that out. And because these devices are plugged in and out, they can be removed, they can change names. This device temporary file system is used in order to map these devices to actual names, and it happens upon startup. So again, when the computer is turning on for the first time, and not even only just the first time, but also as the computer is running, the kernel will automatically detect devices that are in the computer. So if we think about removable media, we can think about hard drive, serial devices. The kernel actually goes ahead and creates those nodes, numbers. The kernel actually creates those, the kernel creates those, the kernel creates those device nodes, and it automatically adds them in the slash dev directory. Now, the slash dev directory is then, and that is all handled, and that is all handled in this dev temporary file system, which is pretty cool how that works. In fact, actually, in fact, actually, let's take a look at an example in real time so that way we can see how that works, which is really cool. So I'm going to go ahead and I'm going to actually take my USB here. I'm going to plug it into my computer. And once the computer is plugged, and once the USB is plugged into the computer, now I have to essentially plug it into my virtual machine. And we do that by bringing up our settings. If we go under devices and we go to USB, here is that USB from SanDisk. So I can go ahead and click on that. And now I've officially plugged it into my virtual machine. So let's go ahead and if I were to do an lsblk now, You can see compared to before that I have SDA, SR0, now I have SDA, SDB, and SR0 now. So this SDB that was just added, this is my USB drive, and it's 114 gigs in size. Let's bring up the df command and see what we get there. Now, if you're wondering why, now if you're wondering why, now if you're wondering why my SDB did not show up in this particular output over here, well, it's because I haven't mounted the flash drive to a mount point. And that is going to be another topic for another video. And we'll get into how you mount things because it is very, very important. People don't realize you actually have to mount a USB in order to be able to read the contents of the USB. So, so now moving forward, now, all right, so let's move on really quickly because I don't want to make this video super, super long. But let's take a look at how we take this df command and let's make it a little bit easier on the eyes because I'm not going to sit here and try to tell you what that available number is. Like that's a little ridiculous. So let's use the df command. So df, and we're going to pass through a flag by using the dash, and we'll use capital H. And capital H stands for human readable, and specifically it stands for SI units. So for those who are in the engineering space, like I've been trained when I went to college, you have to know what the SI units. You have to know what the SI units are. So think about kilo, mega, giga, 3, 6, 9. That's what that H is for. If you use lowercase, I always pronounce this incorrectly, but lowercase. So lowercase h, it gives you in. Let me see how you pronounce that actually. So lowercase h is so lowercase is your binary prefix. So that'll be like key. So that'll be like kibibytes versus the SI version, which I'm going to use here, which is the dash H, and that's what I was trained in college. That would be kilobytes. And so we'll take a look at the difference. That way you can see the two. But if you're interested, go and take a look at what is the difference between kibibytes and kilobytes, and you'll see that there actually is a big difference in calculating space. So let's hit enter here. So you can see here, this is what the big H is, which is the SI version. Let's take a look at what the binary prefix would be. So if I were to do df lowercase h, there is the binary prefix. Now you can see here that the SI calculates and gives you a different size versus the binary prefix size. So take your pick, which one you like. I'm personally, because I was trained in college, I use the SI version a lot. That's just the way that I find it to be a little easier. But you can see here that if we were to take a look at the SI, dev, the dev temporary file system is 4.1 gigs in size. You have a 35 gigs for your rel home. You have 70 gigs for your rel root. And it makes it a lot easier to view this because, again, both are human readable, but it just depends on, do you want binary prefix or do you want the SI internet or do you want the SI version? It's up to you. All right, so the last thing that I want to teach you guys before I wrap up this video is the du command. So let's take a look at the du command. So if I were to do a man du, it tells us that it estimates the file space usage. So you can go and take a look at the description and see what is available as far as flags, so on and so forth. So if I were to run now the du command, you can see that a bunch of stuff came out. And in fact, actually, there was so much that we missed it all and it went off the screen. So essentially, it gives you the disk usage. And if you were to do du gives you the disk usage at the root level. So remember, that is the default. That is the default. That is the default behavior if you don't tell it anything else. So let's go back to our lsblk command so that way you can see what I'm interested in. And let's say I'm interested in seeing the disk usage of SDB, and that was that flash drive that I plugged into my virtual box, or my virtualized, guest OS, which is rel. So if I were to do a du, and let's do it on dev, and remember, SDB lives in /dev, and we talked about that before. So let's do SDB, and let's hit enter and see what we get. No. So now let's say I want to see the disk usage for the VirtualBox guest editions that I have put in through that virtual CD-ROM drive. And let's say I want to take a look at SR0. So I can do now a du for disk usage. And let's go under dev SR0 and see what we have. SR0. No, let's figure this out. Now, let's say I'm interested in taking a look at how much space or how much disk usage is being used by my guest editions. And remember, the guest editions was that disk that holds essentially the software that makes the operating system work. And when I say the operating system, I'm talking about the guest operating system. It makes rel work with Windows very well. There's features that you get such as drag and drop and a few other things that allow this to work. That software lives in this virtual disk that I have here, which is called SR0, right? That's my guest edition, my virtual guest edition, my virtual box guest edition. So if I want to see how much space is in there, we obviously know the size of the disk is 57.4. Okay, cool. But let's take a look at even further what's inside of it and what makes up that space. So if I were to do a du for disk usage, and we're going to go to the mount point, and here is our mount point, right? So I can take a look at /run /media /lacosta /vbox, so on and so forth. And by the way, guys, you can highlight the whole entire thing here, right, with left clicking, and then you can use the middle button on the mouse in order to do copy and paste like you saw me do quickly here. That's one of the tricks that I'm pretty sure I talked about before, but if I haven't, you're welcome. So now let's hit enter here and see what we get. And you can see here that it actually goes in and recursively looks at all the directories and it tells you the size of the directory. Now, this is over here the size of each of the directories. So all of these actually, if you add them together, it equals the 57.4 megabytes per second. Now, if you're wondering and you're saying to yourself, gee, what is that? How do I even read this and make it easier make this easier for myself? Well, just like the df command, you can actually have the same. Well, just like the df command, the flags actually work here similarly. So if I were to take the same command as before, and we were to do a -h, remember, big H is SI, Little h is little h is binary prefix. So I'm going to say big H, and let's run this and see what we get. No. Ah, let's try this again. Let's do that again. All right, ready? 3, 2, 1. No. So the last thing that I want to leave you guys with is so the last so we touched on that we touched on DU, right? Disk usage, and we talked about how you can find it, and I showed you a little bit about what that looks like as far as the space goes. And by the way, let's take a look at that real quickly again. So if I were to do a DU, so the last thing that I want to talk to you guys about, oh Jesus, this is turning out pretty bad. Let's do it again. So the last thing that I want to talk to you guys about before I let you go is the DU command, or the disk usage command. And this one's really interesting because it allows you to see what is the space that is being, no, because we talked about it already with this. Jesus, let's do this again. Ready? 3, 2, 1. All right, so I showed you guys the DU command and how you can use the disk usage command in order to see what space is being taken. What? So So now that you guys have seen the disk usage command or the DU command in order to see the space that is being taken up on disk, it's interesting because again, we talked about all the directories that it's interesting because it gives you a it's interesting because you saw that it gives you a lot of output. So how do we control that for something a little bit more meaningful? And as an example, guys, let's take a look at this last thing that I want to look at here, and it is SR0. And SR0, as we talked about before, is our virtual box software, right? We have to install that on our guest operating system, which is RHEL, in order to smoothly interact with our host operating system, which happens to be Windows. So if you're wondering, well, here I'm seeing the size of that virtual disk, it is 57.4 megs. But have you ever wondered what's really inside of it and how much space is taken up? I mean, the total is 57.4, yes, but is it one directory, multiple directories? Like, what does that look like? And you can actually use the disk usage command in order to figure that out. So if we were to do a du, and by the way, we can do a -h in order to have, no. So once you have du now, once you have DU, you can then go ahead and target the SR0, which is our block device for that virtual CD-ROM drive. So let's go ahead and do a /dev/SR0, and let's see what we get. No, it's not that. Jesus. So now we can go ahead and target that SR0 in order to see how much space is being. Oh, no, so let's cut that out and say. So once we have that du command we can then go ahead and we can target the mount point for that particular CD-ROM drive. And as you guys are seeing here, SR0 is mounted on /run/media/Elocosta/VBox, so on and so forth. And so what I'm going to do now is I'm going to copy and paste the mount point. And by the way, for those who are not aware of what I just did there, you can go ahead and highlight the whole thing by left clicking it. And you can use the middle button in your mouse in order to copy and paste. I think I've talked about that in the past, but if not, you're welcome. That's a little quick shortcut there. So this command now will tell us what is inside of this directory, and it is 57.4 megabytes in total size. So let's take a look and see. If I were to run this command now, you can see here that DU is made up of 1, 2, 3, 4. It looks like 4 total directories. And these are the sizes here: 651, 2146, 6758, and 58,427. So those are the sizes. And the interesting thing is, if you're saying to yourself, well, gee, do I have to guess at exactly what that means? Just like the df command, the du has a -h flag that stands for human readable. So if I were to go ahead and run this, you can see now that it's human readable, and you can see here that, and in fact, actually, this makes it even easier for me because I said this directory here is 58,427. Well, this 58,427 is actually the entire directory here, right? So even I benefited from using the -h flag because I thought it was 4 separate directory, and in reality, you have your most top level directory, which is your /run media Elocosta VBox, and then under it you have these 3 directories here, and you have these 3 directories. So these 3 directories, along with the contents inside of the directories itself, equal the total, which is 57.4, or it's rounded up to 58 megabytes, which is interesting. It's a really cool way of taking a look at what is the disk usage space. It's a really cool way of seeing what the disk usage space is by leveraging the du command in order to give you that information. So anyways, guys, I hope this video has helped you out in understanding some basic concepts. Again, we're going to be building on this stuff. So if you have any questions or you need any additional help, leave me a comment in the comment section below. Also, as well, guys, if you like these videos and they're helping you out in that journey, especially the Linux journey, if you guys like these videos and they're helping you out a lot, make sure you give me a like for the video, as it helps the channel grow. Don't forget to subscribe to the channel. Turn on your notifications so that way you're notified when Don't forget to subscribe to the channel and turn on your notifications so that way you're notified when I upload new videos, especially on the Linux series. And of course, share this with a family member or friend who's interested in learning. And by the way, guys, if you don't want to wait for my next video to drop, go ahead. And by the way, guys, if you don't want to wait for my next video to drop, YouTube thinks that you'll like this one popping up on screen. So go ahead and give that a watch. And I'll see everybody in the next video.